Hi everyone, welcome to another demo of yaci-store. My name is Satya, and in this demo I'm going to show you how you can write your own custom scope indexer using yaci-store as a library. In this demo there are two parts. In the first part we'll see how you can listen to some of the core events published by yaci-store, and in the second part we'll see how you can write your own scope indexer using metadata store. So yaci-store has out-of-box support for Spring Boot. It comes with various Spring Boot starters. Like if you want to use UTXO store, there's a UTXO Spring Boot starter, and if you want to use metadata store, there's a metadata Spring Boot starter in yaci-store. So let's start our demo by creating a new Spring Boot project. I'm going to use my IntelliJ IDE to create a new Spring Boot project for our demo. Let's call it metadata scope indexer. And I'm going to use Kotlin for this demo, Java 21, and Maven as a build tool. Okay, my project is there. And if you can see here, there's a Spring Boot application file, and in the pom.xml, the standard Spring Boot related dependencies are there. Now, if you go to yaci-store website and check here, there are few steps you have to do. So let's add this dependency, a yaci-store Spring Boot starter dependency, to pom.xml. And we're going to use yaci-store 0.1.0. And let's create a application.yml file inside resources folder. And we can delete this default application.properties file. And inside application.yml file, we need to add few mandatory settings or properties. This is the flyway configuration, and the next one is the API prefix for REST endpoint. For other additional properties of yaci-store, you can download application.properties, and you can copy this file inside a config folder in the project. But for this demo, we're going to add all additional properties inside application.yml directly. So the first properties we are going to add here are Cardano host, port, and protocol magic. We're going to connect to a preprod network for this demo. So let's set the host name for the public relay for preprod network, and this is the port, and the protocol magic is 1 for preprod network. We are also going to set sync start slot and sync start block hash. If we don't set it, our application will start syncing from the Genesis block. But if these properties are set, then the sync will start from this point. Okay, so I think we have all the basic properties now to start our application. So our application is now starting, and it should start syncing from the point we have specified in the application.yml file. Okay, it started, but we can't see any tables created by yaci-store because by default it's using a H2 in-memory instance. So what we are going to do now, we are going to add PostgreSQL configuration into our application.yml file, and our target database will be now Postgres. And let's change the schema name to demo. Okay, so next I am going to add this Postgres connection to IntelliJ IDE so that we can see the content of the schema directly inside our IDE. Okay, let's check the connection. Okay, so credentials are okay. Let's set the current schema to demo. Okay, now if you check the demo schema, it's actually empty. Now let's add Postgres driver to our pom.xml. And let's start the server again. Now if you check demo schema, you can see there are three tables: cursor, era, and flyway schema history. Cursor table is maintained by yaci-store. It's basically used to store the latest cursor or latest point during the sync process. Similarly, era and then flyway schema history is basically a fly specific table to keep the migration history. Now let's see how we can listen to some of the core events published by yaci-store. Let's create a class called event handler, and let's annotate this with component annotation, which is a Spring Boot annotation. And let's create our event listener method, and we're going to use event listener annotation here, and let's call the method handle min burn event, because we are going to listen to mint burn event, which is basically published whenever there is a mint or burn transaction. Now if you check here, these are all the code or core events published by yaci-store after reading the on-chain data. There are other derived events; those are like specific to different stores, but we can cover that in another demo video later. Now let's see what we can do inside this handle event method. Basically, you can capture this event, and then you can do whatever you want to do. You can publish a message to message queue, store it in a database. But what we are going to do here, you are basically checking if there is any min1 event. If it is there, then we're printing that payload as JSON. Now let's start this application again. Now if you see, it will start printing the payload in JSON format. Yes. Okay, this is how you can listen to any of the core events, and this is also true for the derive events. This is the same. You have to follow the same process for derive events, but we're going to go through derive events in one of the future videos. In the next part of the demo, we're going to see how you can write your own custom indexer using metadata store. But before that, let's go through the design, store design. Okay, if you see here, these are the different components of a store, and each store has a component called storage, and the storage component basically defines storage API, which is basically a standard interface for every store, and out of box every store comes with the default implementation of storage API, which is specific to RDBMS database like H2, Postgres, or MySQL. But you can always provide your own storage implementation for a specific store. So what we're going to do here now, we're going to include metadata Spring Boot starter. Let's copy this dependency and edit this to include metadata Spring Boot starter. Okay, so now save it And let's drop all the tables in demo schema and refresh the pom.xml, and let's remove this event listener code here. So now this is basically a empty Spring Boot project. Let's start the application, and now if you see here, the application started, it started syncing. And if you go to the demo schema again, you can see um, all the tables there, and there's a new table here, transaction metadata. If you go there, you can see our application has now started storing metadata, and it's basically storing metadata for all the labels. Out of box, each store also exposes some of the default REST endpoint. So these are the REST endpoints exposed by metadata store, and let's use this API endpoint to get all metadata with 721 label. So did you notice we just have a plain vanilla Spring Boot project without any custom code. We just added a Spring Boot starter for metadata store, and it started capturing or started storing metadata records into the database. So, and this is true for all other stores. Now let's see how you can customize this default behavior. That means, let's say you don't want to store all the metadata in your database. You just want to store only application specific metadata or the metadata specific to certain labels, right? So let's create a class called custom metadata storage IMPL. So what we are going to do, basically, we are going to override the default metadata storage IMPL. Um, so our custom metadata storage IMPL is going to extend tx metadata storage IMPL, which is the default storage implementation for metadata store, and we need to add constructor parameters. Let me do that. Okay, now what we can do now, we can actually override this save all method. We can provide our custom save all method implementation where we can add a filter logic to filter metadata list based on, let's say, label 721 or NFT metadata, and then call the save all method of superclass, and we pass this filter list. Yes, so that's it. So we're passing this filter metadata to save all method here. Yep. So just by doing this 3-4 lines of code, we'll be now able to only store metadata which is labeled 721. So we started the application. So let's go to the demo database again and check this table, transaction metadata table. Yeah, you can now see it is only storing metadata with label 721. Now let's go to the Swagger endpoint and then check the endpoint. Yeah, so out of box, as I mentioned earlier, out of box we get these default endpoints, but we also have an option to disable these endpoints through application properties or application.yml. Let's try to disable these API endpoints which are provided by metadata store. So let's make this flag false and again restart the application. Okay, the application been started now. Now if I go to Swagger endpoint, can see there is no API endpoint exposed here. So this is one of the way how you can customize the behavior of default store by overriding the default storage implementation. Thanks for watching this video.